and thank you so much. So, good morning, everybody. We are about to begin our class number 20.1 because we have a 20.2 in the evening as well. And today we have with us Debbie Saunders, all the way from Australia, to share her story, to share her experiences, and her passion for using drones for wildlife. And so, with this talk, we will make a shift from agriculture to conservation and gradually moving towards why we need to conserve the natural resources, the earth, the wildlife, and everything that's beautiful on the earth, minus humans. So, that's where Debbie is going to talk to us about. And she has done amazing work. I'm a big fan of what she does. And today she's going to tell us all about what she does. So, over to you, Debbie. The class is yours. Thank you.
Fabulous. Thank you so much. It's a real honour to be here and to have the privilege of speaking to you all. I look forward to the discussion and actually finding out more about yourselves as we go through today. So I'll just share my screen. Okay. So yes, Wildlife Drones is my startup business that I have right now. But I haven't always had a business, and I haven't always been into technology, if you like. I'm actually a wildlife researcher who had a problem, and I tried to solve that problem. And then in doing so, I stumbled across a fact that many other people have the same problem. So what I'm going to share with you is just a bit about the journey of where I've come from and hopefully where we're going, and share a few insights about that journey and the technology itself. I don't know if you normally do this as part of your classes, but I really love to find out who it is I'm talking to. So maybe as I'm presenting, you can perhaps in the chat box, which I can't see right now, but I will after I stop presenting, what is your name and where you are calling from, whether you have ever monitored wildlife, and if so, what wildlife you have monitored. So I've looked at the webpage and seen the wide diversity of topics that you are covering. And so many of you may not have had anything to do with wildlife, and that's completely fine. Hopefully you'll find this enlightening and maybe something a bit different to what you've heard about before. So I'll start with my journey and my wildlife research that I have done. So for many years now, I'll just put it into presentation mode. For many years now, I have done research on this small green parrot that you can see here, which is called the swift parrot, and it's critically endangered. Its numbers are very, very small, and yet it is fascinating. It migrates, so it breeds in Tasmania, down in the southern end of Australia, and it migrates north for the winter, a bit opposite to those of you in the northern hemisphere. But they feed on nectar of eucalyptus trees, and so they need to search for that nectar across really vast landscapes, and it goes to different places in different years depending on where that nectar is. But one thing that now my arrow buttons aren't working. Okay, a bit strange. Oh, there we go. And so we know that they move around, but nobody understands their movements, like how they know to go to one place versus another place. And people had tried to radio track them because they are a small animal. The only way you can really track an animal that is not much bigger than the size of your hand is to use a radio tag, a very high frequency radio tag. And at the moment, the only real way of tracking them is using handheld equipment. Well, until now, handheld equipment, and one animal at a time. So it's very, very challenging when you have a small animal, a big landscape, and a tiny little signal from a tag. And this is one of the main ways that small animals are tracked all around the world, using the same thing. Walking around with your arm up in the air for hours on end, searching for the ping, ping, and trying to find it, one animal at a time. And you can get the best signal by getting a different angle or getting higher so that you get a good line of sight with the actual tag. And that's what all these people are trying to do. Get up on top of a mountain, on top of the car, in the canoe can give you a different perspective. Helicopter is the ultimate in high, or teams of people walking through a landscape. So people will go to extremes. They've got a lot of time and effort to tag these animals. And the reason they want to tag the animals is to understand their movements. And the reason they want to understand that is that they really want to either improve the conservation of that animal. They need to understand where it goes and what it does. But if it's an invasive species or a pest species, you might want to be able to control that species to reduce the impact on the environment that it's having. So I was at university. I was studying myself. I was a student, and I was doing research on these birds. And I had a colleague doing research on lions. And even though that was on the other side of the world, and some of you may be from areas where lions occur, he was lamenting about just how hard it was to track even this quite large animal, and that some of the other technologies, satellite technology, what have you, weren't giving them the real-time data that they needed to find those animals. So that actually sowed a seed in my mind, and over a number of years I started exploring whether it might be possible to use a drone to track these animals. And this was quite a long time ago now, and so hardly anybody had any drones or knew how to work with drones. And so the partnerships were quite limited. But we did find some robotics people who were quite familiar with drones, and we managed to get some funding for a few-year project to study the swift parrot. Unfortunately, we had challenges in that project as well, because the swift parrot is also very challenging to attach a tag to, because they scramble through branches and go into hollows and things like that. So they are very susceptible to getting entangled. So we weren't able to put a long-term attachment on the birds. So we switched to another bird, which is the noisy miner. Here is a very common woodland bird, just to show that our technology that we had developed over a number of years would actually track a live animal rather than just a tag sitting on a post. And we were able to do that, which was fantastic. So we had a whole bunch of partners, zoos who were involved in captive breeding programs, government departments and universities all working together. And it was fabulous. We were able to demonstrate that. But what also became evident, as with most new technologies, is that as soon as you discover one thing, you uncover another raft of things that really do need to be improved. So we'd proved it was possible, but we'd also discovered there were many, many limitations to the system we had developed. It could still only track one tag at a time. We couldn't pick up the tags very far away. It was radio interference issues. So if there were some other signals, we couldn't hear our tags. It only worked in Australia rather than anywhere, and a really, really short flight time. So we were trying to track these little bettongs here. They're like a little tiny kangaroo, and they live in the grasses. And as soon as you get close to them, they would bolt. So it was a great idea to track them from the air, but all these challenges arose on that time. So I then, but we had no more money at that point. So that was the end of our project, unfortunately. But people from around the world started contacting us and to find out whether they could also get their hands on this system. And I'm like, well, you could, but there's actually all these problems with it. So we need to fix them to make sure that it's usable for people. So over the past 3 years or so now, I've pulled together a whole new team of people, and we've learned a lot of lessons and have come up with various iterations of a new level of technology that addresses all of those problems. So this picture that you can see here is just a DJI Matrice 210 drone. So it's an off-the-shelf drone from DJI, and we just attach our radio tracking system to it. So on the top there's a little square box with an antenna. That is our radio receiver box. And across the legs, you can see there's an antenna with some elements across the bottom there. So we have this system now, and it is actually capable of not just doing 1, but 40 animals all at the same time. We also can pick up the signals from greater distances than ever before. And we have real-time data analysis and mapping. And I think this is a really critical point in terms of drone use, because many, many drone applications rely on visual information that needs to be processed after the drone comes back. And that is a lot of work and a lot of processing that needs to happen there. We actually do the processing in real time. So the data comes back from the receiver to the base station laptop, and it gets processed in real time. So you see your results immediately as the drone is in the air. We've also got some pretty smart algorithms in the background now that deal with those interference. We can track any VHF radio tag globally rather than just the Australian frequencies. And we also found out, just kind of by accident through some customer projects, that we also can download GPS data from close proximity tags on animals. So there's a whole raft of things that we're now capable of doing that were never possible before. So how does it work? Well, first of all, the animal does have to be tagged. So there's many drone applications where you're using visual cameras to look at how many animals, counting animals, and that's really great for certain applications. But if you want to understand the movements of individuals and where they're going and what they're doing, you really need to have them tagged. So once the animal is tagged, you simply need to attach our system to the Matrice 210 or an equivalent drone. Our payload weighs approximately 1 kilo, so it needs to be able to carry that sort of weight. And then you fly the drone and you'll be able to see your results live on a map on the base station. It doesn't require internet connectivity when you're out in the field. You can download maps when you're somewhere with internet, and when you're out doing your tracking, all of the maps will be there, so you don't need to have any connectivity. We've built a really simple user interface that has some complex things happening in the background that you never even need to see. We have a file system whereby you work from the top down to the bottom on those buttons on the left, and that will take you through everything you need to do. Once the drone is in the air, you'll see signals, and in this case, we have 4 tags that have been entered, and the graph on the bottom has a line for each of the tags. So for each tag has a unique frequency. So our system listens for that frequency and it plots the strength of that signal. So as soon as it is picking up the signal, you'll see a peak on the chart like that on the bottom of the graph here. And you can see immediately that that animal is in the area, and that in itself can be enough of a result. Once you get a bearing from the first rotation. So you do a slow rotation and you listen to all the signals in a circle, and then you get a direction for where that first signal is coming from. You fly to another location and repeat that, and then you start to get lines that are intersecting, and that's when you get your coordinates on the map. You can also just click on each of these locations, and a pop-up will come up with all of the information about each of those animals that you've put into the system. You literally just have to take the out of the box that we provide the whole system in, put it on the drone, and you're ready to use the system straight out of the box. To give you an idea of the projects we've worked on so far and the interest that we've had, we certainly have had inquiries. All of the places that are coloured in green here, we've had some sort of contact from someone who's interested in this system. It's been quite global in terms of the interest. We're in Australia, Vietnam and New Zealand is where we have implemented our projects so far. But we would really love for it to be used much more broadly as our business grows and as people become more aware of what the capability is. It doesn't really matter what type of animal it is that you want to understand. A radio tag can generally be attached in one way, shape or form. So whether it's a reptile, a bird, a mammal or an amphibian, a radio tag is often a really good way to collect data on their movements. Just to give you some examples now of the types of projects that we have actually applied it for, I was actually able to at last track my favourite little swift parrots. We discovered a short-term attachment method from some other researchers working on water birds, and the parrots actually will just chew the tag off after a while. So there's no entanglement issues. We were able to track them during their during their winter foraging season, and actually for the first time find these mass roosting locations and the foraging locations and be able to look at how many animals are coming together every evening. We've also been able to track goannas. This is like a giant lizard that lives here in Australia. They're not dangerous at all. In fact, they're really passive and beautiful. But they do love to hide down burrows, and so that can make it very difficult to track because they're very shy. So when people research them, they find it difficult to get close and observe them, whereas from the drone, we can collect the data from further away. Because we use triangulation, we don't actually have to get close to the animals. In fact, it's better that we keep away, and therefore their behaviour is natural behaviour rather than us interfering with it. So I think that is another key benefit for some species like this one that are really quite shy. We also have been to New Zealand where we tracked kakapo just recently before COVID struck the whole world down. And we were really fortunate to go here. This is a very rugged, remote island with dense vegetation. And these birds are down under this thick vegetation. And so we wanted to test it out. And it was really exciting because we were able to pick up many, many birds all at the same time, which was equivalent of weeks' worth of work for people on the ground to track those birds. We've also just recently been out tracking orange-bellied parrots, which is, again, another small migratory parrot. But these ones live in salt marsh, so they're in swamps, very boggy areas with mangroves around, vast coastal areas that are very, very difficult to survey from the ground. So the drone was a fantastic way to be able to search for these animals once they'd been released. These were actually captive bred animals that were released to try and bolster the wild population. And as I mentioned before, we have been up to Vietnam, and this is a really wonderful project where Save Vietnam's Wildlife are rescuing and rehabilitating pangolins from the medicine market, which hopefully will be reducing in size after all of what the world is currently going through. And we've been able to, we went over there and we're able to show them how to use the system just for a short period of time. And now they have a system there and they go out whenever they need to and track their animals. And they've been able to track more pangolins than they ever have before and with greater ease. And the landscapes they have to work in are very difficult. You can see one road there and that is the only access in this whole area. So it's very, very remote, very steady and very and this drone has and they haven't had no problems with understanding what was required, operating the drone, collecting the data. In fact, they've been really quite remarkable and on top of the whole thing, it's been really wonderful working with them. So that just gives you a bit of an idea of the different sorts of applications and yeah, I think that's probably all I need to say now. I think it's sort of probably open to a discussion. Is that right, Ruchi?
Hello to everyone, this is Amit here. So I'll be taking on the questions from all the attendants here.
Okay.
So the first question comes from Dilip sir. Won't the noise from the drone scare away the animals or the birds?
Well, it's interesting. It's a good point. So I think that the fact that we are actually able to track the animals from a distance rather than needing to go close to them, it means that we're actually disturbing them less than if we were tracking them by hand. To track them by hand, you typically would walk very, very close to the animals. And so it actually can be less disturbing. And when we were in New Zealand, we had a lady come out with us from the local Indigenous community, and her role was to observe the impact of the drone on the wildlife, because that was something that they were concerned about. And so her observation was that because we actually were flying quite high above the canopy, that we had much less impact on not only the animals we were tracking, but the environments that they live in than any of the tracking that happens on the ground. So I think it's a really good point to be aware of. And I think a lot of drone applications are quite invasive of animals and scare them away. But with our technology, you don't have to do that. So I think that's a benefit.
So, how were the animals tagged? Like, whether the rescued animals or they were caught and they were tagged?
Sorry, what was that?
Like, how did you tag the animals? So were they rescued from somewhere and tagged? Otherwise, they were caught or tagged and then left in the wild.
Ah, right, yes. So in some cases, if they're a captive bred animal, they're already in captivity and they can handle them, put a tag before they release them into the wild, like the pangolins and the orange-bellied parrots. For the other animals, they are wild animals, and typically the people who want to do the tracking are researchers who, for example, for the birds, there are special nets that you can use to catch them that won't harm them. And if they're a mammal, you might use a trap or some other attractant that you can use. So it depends on the animal and understanding the animal as to knowing what is the best way to capture and safely handle them so they don't get too distressed.
Okay, so there's a question from my side also. Mostly I found out the parrots that you were tagging were belonging to the Psittacidae family, probably.
Sorry, I didn't quite catch the question. Could
To
you
the
repeat?
family Psittacidae. It is the like category to which these parrots belonged, the old world parrots.
The parrots?
Right, the orange-bellied ones and the swift
Yes,
parrots.
the
Okay,
orange-bellied and the
so
swift
like
parrots.
they were tagged in their origins or in some areas that they had migrated to.
So we were tagging. Both of those ones were studied in the wintering area. So they were just foraging in that area. So they weren't nesting at the time. And so for the orange belly, they were captive release. So they released them as a group and they were there together. And for the swift parrots, they also will occur in groups. We don't know anything much about their social structure within the group because it's been very difficult to track them and understand that. So we just catch a small number of them generally, and tag them and then see what other birds might come to them, and we just observe them.
Okay, so there's a question from Rohit. What is the standard height at which the drone needs to pick up the signal?
So the height we fly the drone at really depends on the vegetation or the landscape that you're flying in. It doesn't have to be particularly high. You can cover more area if you go high. Here in Australia and in many places in the world, the limit is like up to 120 meters. And so we're not allowed to fly above that without special permission. But typically, I normally fly at about 40 meters or maybe 50 meters. But if I'm in a tall forest, I might have to go a bit higher.
Sindhav is asking, are there any side effects or bad effects of the radio tracking to the animals?
Sorry, are there any other
Any side
impacts
effects
on
or bad effects of the tagging?
side effects of tagging the animals? Well, that is something that needs to be determined for each species. So typically the tags are designed for a particular animal. And so for a bird, though, maybe in this case for the swift parrots, I just actually taped it onto the feathers on the back, and so it can be removed by the bird over time. For other animals, if they need a collar, that collar needs to be specifically designed for that type of animal. So the pangolin, for example, has a very different type of attachment. And yes, if the attachment is not done right, it can definitely have an impact on the animal, and that's really critical. And it's typically people are not allowed to tag animals unless they have an ethics approval, whereby they explain exactly how they're going to tag the animal, and that gets approved that is something that's not going to impact, which is why we did the tests on the swift parrots that were in captivity before we did anything in the wild, to understand what we needed to do to make sure that we didn't have any bad side effects for the animal. So in the end, we were able to find that out. But it does depend on the specific animals that you're studying. Yes, I have. Well, when I say incidents, there's been interest, I guess, from my perspective. Yes, look, we have some big raptors. We have wedge-tailed eagles that are our biggest eagle, and I have one that goes to my flight testing site. Often it might be curiosity and things like that. So I did get some advice from another drone pilot once, which I think has been really great. In that if a raptor or a bird of prey shows an interest in the drone, I maneuver the drone upwards because they tend to attack or approach things from above. So if they're coming in, if you actually raise the drone up, it often is enough to deter them, and then they just move away, and there's no interaction. I have had one instance when I had a very curious swamp harrier that was much more agile than an eagle, and so it kept. I would go up and it would go up, and then in the end, I was just like, oh, okay, look, obviously I'm annoying you, so I was about to leave, and then it actually lost interest and moved away. So I think you always have to pay attention, because you certainly never want to strike an animal while you're in the air and badly injure the animal. And your drone will no doubt fall down, but the animal will be left injured as well. So I think I do actually I have a strobe light, like a very bright light that I put on top, and I have some reflective tape as well. I don't know if it's effective or not, but I do that to try and I guess, make it less likely that the animal will want to actually approach the drone. So that certainly happens, and I think you need to be aware of it. And if it looks like the animal is going to really try and attack the drone, then I think you just have to pull it out and think about that animal.
Okay, even I have seen in some cases, like I have seen in Nat Geo and other channels, that they take some trained eagles or other attack birds there, and they try to drive away the birds present there so that they can do the operations.
Yeah, I don't know. I think you would have to question, what the operations are and what's required and whether that's necessary. Yeah. I think it can certainly. I think there's a lot of videos on YouTube of inappropriate use of drones as well in terms of wildlife, and I find them quite distressing to watch because it's so unnecessary. And if we're in the air and they're there, then we need to respect that that's part of their home range, and you kind of sometimes you might just have to abide by their rules instead of our own.
Okay, so Samiksha is asking, can we track other animals using the same methods, like rhinos and others?
I think I'm not aware of others using a system like this one in Africa, but I think, or anywhere else, really. I mean, there are some people in Canada who've been trialing some things, and maybe some in the US who've developed some in the universities, but I don't think they've been applied to species such as rhinoceroses. I think that would be really valuable. I have been in conversations with people where they have put radio transmitters inside the horns of rhinoceroses, and I think that there potentially could be some quite good scope to use the system in terms of monitoring human wildlife conflict areas or poaching and that type of thing. So I think there's the potential applications there, definitely.
The same tech can be used for cattle also?
Yeah, so it's possible to track cattle as well. It doesn't have to be wildlife. It can be really anything that you want to put a tag on. So you could even have people with tags if you want to know where your people are. It doesn't matter what the tag is on. It just needs to be a tag that's emitting a signal. So yeah, it could be cattle, or it could even be equipment, or it could. There's some cases where people have similar tags on traps as well, and so if they're trapping for some animals, they will get a different signal if the trap has been set off, and so that helps them monitor the traps more efficiently and in a more ethical way. So there's also those types of applications, which is it's quite interesting. I love hearing about different people's stories. So that there's always another application you've never thought of in different contexts.
Okay. So, can this tech also help in avoiding human-wildlife conflict?
I think so. I think you'd have to think about the best way to use it, and make sure that it's in the right hands. And but I was speaking to someone the other day who really just wanted to be able to keep the people safe enough away from, say, dangerous people, so that they actually can do their work and protect the animals, whether they be cattle or wildlife, without endangering their lives, because people have actually been losing their lives trying to protect animals. So they were interested in the potential for using this system to understand where the animals are and where their people are, so that they can make sure that they're actually able to track those movements and things without endangering their own lives. So I think that there's also perhaps early warning systems, if people can keep track of large animals that might be having an impact on a community. Maybe they could track their movements and understand where they're going without the need to buy really expensive tags, the GPS or satellite tags that might not be viable in terms of the finances that are available to do the work.
So the tag is a RFID tag or a GPS tag?
The tags are they're made in a number of different places around the world. We don't make the tags; they're just a standard tag that is used for tracking wildlife. And typically, each country will have its own sort of bandwidth of frequencies which are allowable for tracking animals. And also the GPS and satellite tags typically have a radio signal as well, because they're quite expensive tags, and people often want to get the tags back as well as track them. So all of the tags tend to have some form of radio signal that our system can track.
Okay, so Anil is asking, is it possible to map the animal population with the system?
To map the population?
Animal population.
Excuse me. Well, we do use we do map the animals, so we map the individuals that are tagged. In terms of the broader population, you could, if you were interested, you could tag a portion of the animals and track their location, and you might like to actually add a camera to the drone and fly that and get an estimate of the numbers with the tagged animals. So you can map out the animals, but you don't necessarily need to have all of them tagged if you've got other ways of measuring the numbers of animals in a certain area.
Okay, so even I have heard about some cases where the wildlife conservation people tagged few of the animals and left them in the wild so the poachers can catch them, and they then tracked them and caught the poachers there.
Yeah, so I think you can get creative with this sort of thing and find ways of a bit different way of approaching these things and being able to track people who are doing good things as well as people who perhaps are doing bad things. So there's definitely some scope for that as well.
Okay. So Rohit is asking, has the system used during the night?
So it's used the same, but you just need to have the skills to do the flying at night, I think is
right, because
truth.
RFID doesn't need to have day or night, because it is a radio frequency tag, so it won't need any specific light requirements. Rather depends on the UAV and the pilot.
That's correct. So the tags will ping all the time, pretty much. So whether you're tracking them in the day or in the night is not important in terms of collecting the data. But some animals obviously are nocturnal, so they'll be coming out at night, and others will be active in the day. So that might change when you want to fly. The main thing, you want a drone that has some good lights, so you'll be able to see it. And you want to have some experience in flying at night, so that you're able to make sure that you have a safe operation in the air.
Okay. Manisha is asking, there are laws for wildlife species, so you have to take legal actions for that. And how cooperative were the local authorities regarding that?
So locally, it's been really quite wonderful. Because I have always been a conservation researcher, all of the work I do is for conservation. And so typically a lot of the people who I work with, they actually work in the government and are involved in these programs. And if I need, sometimes I might need to get a permit to go into a park or a reserve. And I haven't really come across too many problems with that. Sometimes there might be a lot of paperwork that you have to go through, but often I find there's actually other ways. Like sometimes you can actually, as long as you launch and land the drone outside of the reserve, you can actually fly over the top, and that's okay. So it varies depending on where you are. But so far, we've been really fortunate. In fact, the place where I do all of my flight testing is actually in a nature reserve here close to my home. And I'm allowed to go there whenever I want because I have my license and I have all those things. So I'm able to go and do that.
Okay, so Anil is asking, can you explain about real-time analysis and mapping?
Sure. So while the drone is in the air, the antenna is listening for those signals and sending it to a little onboard computer. On board, there's a little bit of processing that goes on, and what it's doing is actually selecting all of the signal data that we want for each of the tags that we said that we're going to track. So it will send down little packets of data back to the base station. So one of the things that I think is really valuable about that is that people sometimes are concerned that, like if a poacher, for example, got their hands on the drone, then they might be able to tell the location of the animals, but that is not the case. So there is just raw signal information on the drone, and that is sent to the laptop base station. And when it gets to the base station, that is where the actual locating comes in. We run it through some algorithms and some filters, and you'll actually see it all in real time on the map and on the signal chart. And based on that information, you can see the locations. So there's actually some embedded software on the drone, and then there's also some software on the base station laptop.
Okay, so how important is internet and electricity in such projects?
Well, it's only important before you want to go and do your work, I suppose, because batteries need to be charged for the drone and for our system and for the laptop. And the internet is only needed if you want to download the maps that we provide. So we provide maps that you can download, and then they're available offline. So we've got both topographic maps as well as satellite maps. So you can choose which type of map you like. But once you've got your batteries charged and your maps downloaded, you don't need any connectivity or electricity when you're out there doing the tracking. And that is the case for most of the people who use our system.
Okay, so there's a question from my side also. So, for example, if a single area is affected by, for example, let's say bears or let's say elephants or something, so they can tag one of the bears or the elephants and then keep the trackers at the gates or the entrance of the villages and other stuff, so that they can track the animals entering there.
So the question is, would they want to tag the elephants and then keep tracking
So basically,
them?
sometimes villages and other settlements get attacked by animals. So, so if the elephants have a leader, bears have a leader who leads the group to a particular location. So if the leader is tagged and
Yes.
the areas by which they enter the village is also having like GPS, the track reader or something, so
Yeah.
then probably it will solve the issue there.
Correct. Yeah. So it could be that maybe depending on the timing, like if there's a particular time when the elephants tend to come in through that area, each day there might be someone who just launches a drone and searches for a certain distance around and see whether any of the signals from any of those lead animals are in the area. That would definitely be something that could work.
Okay. So Anil is asking, is the data encrypted that is being sent to the base station?
So the data is raw signal data, and it really won't make any sense until you put it into some software that makes sense of it. So in a way, it is. Yeah, it can't be used in its format in that way. It's not until it goes through our software and algorithms on the base station that any real sense will be made of it. So, yeah. And we also have the laptop, the base station has encryption embedded into it as well. So if any issues happen to the laptop, then it's encrypted.
Okay. So Caerobotics asking, how about live tracking is can it be done offline?
Yeah, correct. Because we have our own communication system between the laptop. So we have a transceiver that we sit on the top of the laptop. It just clips on, and we have the antenna on our radio receiver, and so they just talk to each other. So that's how we get the real time information. Now, that real-time data feed, we've tested it out to about 2.5 kilometres away, and it still can do that for up to 40 animals. If you flew further than that, you wouldn't be able to see your drone anymore, but sometimes people might want to do that. It will still collect the data, and when it comes back in range, it will catch up and hand the data over.
Okay.
Yeah.
So, would you like to talk a bit about the RF chips that are being used? Because people generally think like it is very similar to a phone, so we have to switch on the internet to get our location. So it is not very clear similar to that. Rather, it is only radio frequency that is working. So, would you like to put some light on that?
Yeah, sure. So it's really it's all based around based around the strength of the signal of that tag. So I might just share my screen again and bring up the chart. That might help. I'm not sure if it will help me explain it, but I'll try.
Okay, so there's another question. Are the operations totally autonomous, or you need a pilot to be there always?
So I actually do it manually because the results from the first rotation will give you bearings, and then you will make a decision about where to go next. Now, we actually did develop a robotic system the first time, but then I felt that actually it was not that useful for people. Like people weren't actually looking for a robot. There were many issues with that. At the time, it actually caused a lot of constraints. So we went away from being robotic. I think in the future it will go back to being robotic, and it will make those decisions for you. But at the moment, it's unlike most drone applications where you do have a predetermined flight path. Where you move for each rotation depends on the results that you're getting real time. So you get an arrow that way, you actually want to fly in the opposite direction so you get a nice intersecting line.
And you even need to tackle the raptors there.
And you need to be aware of the potential attack of raptors, yeah. So this is what I was trying to refer to. So these lines here, this red line and the blue line, are indications of the signal that we have received, how strong the signal is. It's the received signal strength indicator. So the stronger the signal, the higher that peak is on the graph. And the red line is the maximum signal that we have received to date. So that enables you to see at a glance, have we picked up that signal at all? And the blue line, which fluctuates up and down, is the real-time signal. So when you're pointing, it's a directional antenna. So when you're pointing the drone in the direction of the tag animal, the blue signal rises up because the strength is up. And when you're pointing away, the blue drops down. And so that's how you get your direction. And the way we get location without any GPS or any other external communications or satellites is we get that bearing, and then we get another bearing from another angle. And we use mathematics essentially to calculate the triangulation point of where those lines intersect. And based around other factors of how accurate we think those bearings are, depending on the signal, the quality of the signal, we then give an estimate of the error around that location. So on this map, you can see that there's a point in the middle and then there's a bigger circle around it. That circle is an estimate of the error around that. We give coordinates for the centre, but then also give an estimate to see how confident you are that it's actually in that location. Because we are using triangulation, there's always a degree of error involved. So we like to communicate how confident we are there as well. I hope that answers your question about the location.
Okay, so as you showed the graph, so blue line is having maximas at some like positions. So how like big is the threshold there? So like what is the distance that shows you the maxima at that point?
So the distance that you can pick up a signal is really determined by the tag itself. So we have tested tags on a really wide range of sizes. So I think someone made a comment there about hummingbirds. So we have tracked tags that weigh 0.8 of a gram. So they are like just the very tiny tip of your smallest finger. And we can find them from 400 to 600 meters away. And we have tracked other tags up to like the size that would fit on a human or a pig or a big animal or even a cattle tag, which is like an ear tag. And you can get many, many kilometres of detection from those. So the bigger the tag, the further away you can pick up the signal. And the smaller the tag, the closer that you'll find that you will have to be.
Okay, so it is basically depending on the frequencies and the antennas that are being used for that, and not basically on the system that is used.
Yeah, that's correct. Yeah. But by putting the drone up in the air, you're at least maximising that distance, you're maximising the potential to catch that signal. So sometimes we are called in to actually help people find animals they've lost. So they have moved further away than expected or something else has happened. And so sometimes they just want us to search. They don't even want us to actually pinpoint things. They just want to know, can I find this animal anyway? Trying to see the truth.
It's fine. Most of the questions are answered already. So thank you for the presentation. It was great. I would request Ruchi ma'am to take over.
Thank you so much, Amit, for coordinating this curiosity session that I'm going to call it. And thank you so much, Debbie, for sharing so generously and so openly about your experiences. And I'm also very curious, I mean, how are you seeing the demand of this technology all across the globe? Is it coming in? People are open for it? They want it?
Yeah, I believe so. Sorry, I'm losing my voice.
Take a break.
Yeah, we're talking to people from all over the globe all the time. And it's really fascinating from studying wolf behaviour in Europe to hornbills in South Africa to pest species in Chile and through the Pacific Islands. So I think there's no end of applications, and it's a matter of people being in the right position to have a drone to do the work, and having the animals tagged to be able to do the tracking.
Okay. And what about, using a similar kind of thing underwater for marine species? Do you think that's possible by using a different kind of rover or underwater drone or something like that? Can be similarly imagined?
That's a really interesting comment. Yeah, look, I think there are actual systems where acoustic tags that they use underwater typically for a lot of marine animals, but they have limitations because they need to have stations in particular, very specific places, and if the animals move outside of that network, they can't see it. So we have had inquiries from people about these types of things. One of the issues with salt water is that it saps the energy out of an antenna or a radio signal. So we have done some testing because I was quite curious about this as well, and I got some buckets, and I must have looked very strange in my nature reserve with these buckets, and I had fresh water and salt water, and I slowly put the tags into the bucket to see the impact on the signal. So in the fresh water, we were still able to pick up the tag signal from a reasonable distance. In the salt water, it was very, very close, like 50 meters. So if the tag is completely out of the salt water, then we can track it. But if it is submerged at all, then it makes it very difficult.
Okay.
But I think, it'd be great to have an underwater version of this, I think.
Why not? I mean, I would be very happy to see the way it all scales up, because this is something that the world needs actually, where technology very quietly, without disturbing the animals, just keeps a track on them.
In fact, I think if you had an underwater drone had a acoustic sampler on it, then I don't see why you couldn't do that. Yeah, that's really cool. Nice
Ma'am,
idea.
can I add on?
Yes, please.
Recently I was studying a case study in which like beach was being attacked by sharks regularly. So what they did is they use spear guns to tag the sharks there, and they spread out nets with trackers throughout the nearby beaches so that they can track the movement of the sharks.
So, Amit, we will be having a full
Yeah, actually,
presentation. Yeah, we'll be having a presentation by Jackie. I'm sure you know Jackie.
Oh, great. Okay.
Yes.
Yes, that's right. And I was talking to someone just recently, and they were interested in radio tracking sharks as well. And I was quite surprised, but he did say that he thought that would be something that could be valuable, where you have sharks coming in where there's people and actually monitoring for safety reasons. So yeah. So I think it's quite interesting. I didn't think that you would. The marine animals are quite large generally that people are wanting to track. And so I just assumed that they would be using satellite tags or something like this. But apparently even they have trouble if they're diving animals, so they don't necessarily get the data that they need. So, yeah, I find it quite fascinating. The more I learn, the more I realize how little I know.
In fact, even in the chat, if you see, there is somebody, Hiren, I think, who is asking about different kind of animals like primates, mustelids, rodents, bats, lizards, snakes. Now he's got very curious. Land turtles, amphibians. I mean, how would you track all of them? Would you need different kind of tags, or would you need different kind of some frequency attached to it?
Yeah, look, that's a great question, and I love it because one thing I think that our system now means is that you can track all different things at the same time. Yes, you would need different tags because you can't put a big tag on a bat, for example, but those little tags I was talking about, they are actually for microbats. So yes, it is possible to track microbats, but they're very difficult. So I would really love a project to use our system for microbats. But it will pick up the signals. It doesn't care if it's a microbat and a monkey and a turtle all in the same area. It just listens for the signals. So it could track all of them at the same time, up to 40 animals at the moment. And so, yeah, it just makes it very possible to study for the first time multiple species simultaneously. So, yeah, it's quite exciting.
I visualize this as conservation scientist. Your primary job is to tag animals.
Well, I used to tag the animals, but now, they're not my projects. I have the tool that people need to actually track the animals that they are expert in. So it's nice in that, they use their expertise and I give them something to help facilitate a collection of data that's meaningful.
Amazing. And if we need training from you, would you provide that kind of training? How do you do that? How do you plan? Like if you have to come all the way to India or Nepal and train us?
Yeah, so we have, we have set it up so it's really quite simple, and it is possible. Like that is what we did when we went to Vietnam. They were one of our first people to come on board, so they wanted us to go there. So we went there for 10 days. And did some training with them, and now they just use it by themselves the whole time. So that is one possibility. The other possibility is that we can do a lot of the explaining of everything remotely, like this, just like we are talking now. Like it's amazing what you can do now. So we can actually. We can send the system to you, for example, and you could set it up, and we could get you to get it going, and we can talk you through that. And you can even start it and fly it, and we can actually help in that way remotely if that was, I think for a while with coronavirus. I don't know how much people are going to be traveling. And so I think there are other possibilities. And the fact that we have tried to make it as simple as possible in terms of easily understand what you need to do. We have a user manual. We have some little videos that can help as well. So I think we have some resources there to help with any type of training that if people are interested, and whether it be in person or remote. Well, we have actually done, for some people, we have done remote training. We just do a video call and they've been able to use it. So, I think there's great scope either way, but we're happy to help anyone who is interested in using it,
Yes,
definitely.
probably business, I'll talk to you offline. But then, there can be a way of probably partnering up with you, because India is a manufacturing destination for drones as well. And the government of India is really looking at scaling up the manufacturing in India. And so that the drones and whatever technology that you need, the sensors, everything can be made available. Probably we could figure out how to do this so that we take the understanding from you and then pass it on, because then we'll be having more localized version of what you're doing, probably.
Yeah, definitely. Absolutely. That's great.
Anyway, so thank you so much, Debbie. I think will come to an end of this session, this amazing session, and which not just brings out the curiosity in us about the world which exists beyond humans, but also gives us a perspective that they also have ethics to be taken care of. They have their own rights, they have their own personal space, which our technology or we should never ever cross. So respecting the space, each other's houses and homes is extremely important when it comes to wildlife. Am I right, Debbie?
Yes, absolutely. Absolutely. And I think that's, the main reasons we want to really protect species and conserve them is for their values. And you need to respect that in any time that you're imposing something on the animal, then you need to do it in the way that will have the minimal impact. Absolutely. Otherwise, all the information you collect is of no value, because you're not getting the information which is from the natural behaviors.
Absolutely. And I think COVID-19 has taught us a lesson that wildlife is a area that you should never disrespect. So you should let them be the way they are in their houses and give them their space so we can all coexist together. So this was an amazing lesson, Debbie. Thank you so much.
Thank you. It was my pleasure. Wonderful to have such an interactive class and lots of fabulous questions. Thanks so much.
Thank you. Goodbye, everybody.
Have a great day.
Thank you so much. We will see you in the evening. And in the evening, we are going to talk about drought. And the drought, I see it as a combination of disaster, agriculture, and conservation. So that will be the topic of the evening class. So thank you, everybody. See you in the evening. Thank you, Debbie, once again.